Let's get 9 marks quickly and without stress with this implicit differentiation problem. This one gives you the equation of the curve, then mention it has only one stationary point at t. So you gotta show that the y-coordinate of that is y squared minus times y minus 2 is equal to 0. So if you ever hear a stationary point, your mind should instantly go to making dy by dx is equal to 0. And of course, this is the exact thing you do here. Just be mindful that each time you differentiate the y, you need to also multiply by dy by dx. So when this d2y to the power of 3 is differentiated, it will turn into 6y squared times dy by dx. I wrote 3 by mistake here, it should be 6. When it comes to the 4xy, you need to treat this as two separate functions, meaning differentiated by the product rule. So doing that turns that into minus 4x dy by dx minus 4y. Factorize the dy by dx and everything that is not a dy by dx just put to the other side of the formula. After that, you can divide both sides by what should be 6y squared minus 4x and you get the differential. At this point, you need to make this equal to 0. The bottom does nothing for you, as the only time the function goes to 0 is when the bottom is much larger than the top, which is irrelevant. So make the top equal to 0 and you get at x is equal to 2y, you have a stationary point. Insert that back into the original equation and you get 4y squared plus 2y cubed minus 8y squared is equal to 0. If you simplify and you factorize, it gives you 2y squared times y minus 2 is equal to 0. And you can divide both sides by 2, giving you y squared times y minus 2 as requested. Easy money. Next is to actually find the coordinates of your point P, and you do that by solving for what y is, which is in this case 2, and inserting this back into the original expression to find the value of x. This gives you a quadratic formula, and you could just factorize it normally. I use the quadratic formula because I was lazy at the time. And you get that the x can only be one value, 4. So the coordinates of the stationary point is 4 and 2, and that's that. The problem looks a bit tough, but it's still more than manageable. It's just the shape looks